This lesson will focus on case studies of exemplar data visualizations. In this video, we'll focus on a data visualization which helped the world understand the true cause of cholera. So by the end of this video, you should be able to describe the role played by data visualization in understanding how cholera spread. As background, cholera is a bacterial infection which can cause severe diarrhea, possibly leading to death through dehydration. After exposure to the bacteria, a person shows symptoms 12 hours to 5 days later, and acute cases can kill within hours if untreated. Unfortunately, cholera is still a danger today, with millions of cases worldwide and deaths in the tens to hundreds of thousands. For those of you who are a bit squeamish, you may want to skip ahead to the video where you see the map graphic. Cholera is particularly dangerous as it can easily cause outbreaks in areas with poor sanitation. People with cholera have diarrhea, which contains the bacteria for up to 10 days after the infection. If someone ingests that bacteria, they contract the disease. So if sewage contaminates food or water supplies, this can cause an outbreak. Today, we know how cholera is spread because of a scientist who had a theory and a terrible outbreak which occurred in 1854 in London. Now in London in the 1800s, sanitation struggled, particularly in poor neighborhoods. With a rising population and lack of proper sewage and sanitation guidelines, many folks lived in terrible conditions. They often got their water from wells, but well water was susceptible to contamination. If they didn't know it was spread through water, what exactly did they think caused it? They actually thought it was a combination of smelling something bad and poor constitution. The first was what led to doctors wearing masks, like in this image. The artwork here actually relates to doctors trying to avoid the Black Death, but the same theory was still present in the 1800s. Bad smells cause disease, and if you could put some sort of perfume in the mask with you, you could avoid those smells. Although we know now that this thinking is flawed, we have the benefit of germ theory. I suspect back in the past, the origin of this idea was likely just a mistaken correlation for causation. Areas where there were people who were ill or had poor sanitation likely had worse odors. And since most people got sick in areas with poor odors, they falsely attributed the smell to the source of the disease. The second idea was a bit more repugnant. At the time, the poor tended to suffer more from disease. Not surprising, given what we know now about how diseases are spread and the conditions in which they lived at the time. But at the time, some people believed poor people were just somehow weaker people, and by their own weaknesses were susceptible to disease. Again, this is mistaken correlation for causation. However, this time is combined with bigotry. So now that you have a decent idea of what they think caused the disease, that leads us to John Snow, who was a scientist living in London in the 19th century. His background was as an anesthesiologist, where he applied scientific principles to make the practice far safer for patients. He'd also published his theory that cholera was waterborne in 1849, but his theory gained little traction. So John Snow is living in London in 1854, near where the cholera outbreak occurred. The outbreak was caused by contaminated water entering the well sourcing the Broad Street water pump. After the outbreak, John Snow went door to door in the vicinity of the outbreak and followed up with every fatal case to find out where they lived and where they got their water. He plotted all these deaths onto a map. This is the full map. It's a bit hard to see, but the Broad Street pump is right there in the middle of all those blocks. Each of those little rectangular blocks was a death from cholera. If we zoom in, we see that there are a large number of deaths in the neighborhood around the pump. Away from the pump, the deaths decline. By talking with the families of the deceased, he was able to learn where victims got their water. And in a perfect example of data science, the outliers were critical for finding convincing answers. There was a workhouse or a prison nearby the Broad Street pump with many inmates, but almost no fatalities. It turns out the workhouse had its own well and shipped water in from a different source, so they weren't using the pump. There was a brewery nearby, which had also escaped cholera. And again, they had their own water supply, or they drank the liquor that was produced in the facility, so they weren't drinking from the pump. Lastly, there was a woman and her niece who lived some distance away from the pump and had died of cholera. With some investigation, he found out the aunt had previously lived in the area and liked the water from the Broad Street pump so much that she had it delivered to her and often shared it with her niece. The combination of this figure and the gathered data that John Snow had put together led town officials to shut down the well by removing its handle. Despite being skeptical that the pump was the cause, the number of new infections almost instantly declined and were quickly stopped. So even though this outbreak was stemmed by the action of taking off the handle from the pump, it took some time before John Snow's ideas were widely accepted. One key piece of this puzzle was provided later by a reverend in the area named Henry Whitehead. He had sought out to prove John Snow wrong, but in the process, he stumbled on the answer to the mystery of how the pump got contaminated. A baby had become ill from cholera in a house near the pump shortly before the outbreak. The parents had cleaned the diapers for the baby into a cesspool near the well, which then seeped into the well, contaminating it. Another key finding related to cholera came some years later, when a German physician, Robert Koch, isolated the bacteria which causes cholera. He did that in 1883. These epidemics and the realization of its cause led to Europe and the United States adopting water sanitation. Snow, for his work, is often regarded as one of the pioneers of the field of epidemiology. I would note that while much of the developed world has access to clean water, the story of cholera is sadly not over, as my numbers at the start of this video told you. The World Health Organization has estimated that almost 80% of people in third world countries lack access to clean water supplies, and in many of those areas, there is no sewage treatment either. Despite our knowing how to prevent cholera, it remains a global health concern. To end things on a positive note, I want to share a picture of me next to the Broad Street pump in London in 2013. I was there for a conference, and appreciating the science and the data visualization in the story around the Broad Street pump. This was actually one of my first stops of that trip. I also want to end with a quick plug for the book, The Ghost Map, the story of London's most terrifying epidemic, How It Changed Science, Cities, and the Modern World by Stephen Johnson. Much of my knowledge about this story came from reading this book. And when I was teaching an interdisciplinary course on scientific literacy and disease at Skidmore College, we used this book as required reading. So I really can't recommend it enough.